Hey guys, welcome back. This is going to be a high-speed review of what to expect on your next test. And then the around the room problems are different, so that's a nice take your time, slower review of what's on tomorrow's test. Okay, so here we go. First, motion of a particle or turtle or a bunny or whatever the heck is moving left, right, or up and down. Make sure you know all of these justifications. These should all be memorized, and notice that they all have velocity in their justification. Okay? The most important two for this particular test are the last two. Distance can never be negative. If I go to school and back, let's say I go to school 20 miles, and then I drive home 20 miles, I drove 40 miles that day, not 0. Okay, so distance can't be negative. So distance has absolute values, but it doesn't matter what my starting position is. Whereas if I ask for the new position or where did I end up, I need to take it into account. Where did I start? And then I also need to know whether it's positive or negative, forward or backward, left or right. So there's no absolute values. Make sure you understand that, okay? A quick overall on that would be something like this. If I just describe the motion of the particle or the turtle, I don't know what this is. Okay, this is a turtle. All right, so what does this mean? Let's just, without answering these questions yet, let's review what's going on here, okay? So this little line segment is off. Hold on a second. Okay, I fixed it. So let's talk about, just in general, what is the turtle doing? Remember, if velocity is positive, the turtle's moving to the right. Velocity negative, turtle moving to the left. I keep calling it a turticle. Okay, so all of this is turtle moving left. All of this is turtle moving right, okay? Positive means above 0. All right. Furthermore, since speed is the absolute value of velocity, speeding up would be right here, going away from 0. Constant speed, slowing down, going towards 0. Again, that's speeding up because the speed here is 0 and the speed here is 2. Even though that's a negative 2 velocity, it's a 2 for speed. So this is speeding up, constant speed, slowing down. This is speeding up, constant speed, slowing down. Okay? Turtle changes directions here. Turtle is stopped here and here and here. Okay? All right, so now let's answer the questions. Hit pause and see if you can do them on your own first. Okay, first you would have to find these areas on your own, the 7 and the 14. So this first one is about where did the turtle end up? What's the new position? Okay, so starting position, and you read everywhere on the test, wherever you need to look everywhere to find starting position. If I ask new position, you need starting position. Okay, it doesn't have to be written in the same sentence. So the turtle starts 2 feet to the left of the mailbox. So 2 feet left of 0, mailbox being 0. What is the new position at t of 10? So the turtle went left 7 and right 14. Okay, so that means that the turtle ends up -9 plus 14, 5 feet. And since it's positive, we should also say right of the mailbox. Okay, versus distance traveled. For new position, I gave this a negative value, but for distance traveled, everything's always positive, distance is always positive, and starting position doesn't change, so it's the absolute value of 7 plus the absolute value of 14, which you didn't have to write like that. It's just 7 plus 14. This just is 21 feet traveled. Hopefully you got those. Okay, so hit pause and do the same thing with this one, please. Let me help you out, though. There we go, because it's kind of a sketchy graph. I didn't do a real good job. Now hit pause. Okay, general description of the motion. Particles moving to the right. Speeding up, constant speed, slowing down. Particles moving left for all of this. Speeding up, constant speed, slowing down. Speeding up, going away from 0, slowing down, going towards 0. Okay? All right, distance traveled. Distance is never negative, so it's 7 plus 6. That one should have been 13, and what is this? Units. Okay, looking at that. New position requires a starting position. This is the starting position, so it's -2 plus 7 minus 6. Okay, so what is that? A -1, so 1 unit to the left, or -1 on the x-axis. Okay, hope that went well. Next one. Okay, now the same questions without the graph, and you will have, this is going to be a 2-part test, 1 page with the calculator and 1 page without. With the calculator for these is so much easier because you just have to memorize those 2 rules, one for distance traveled and one for new position. So if it's a calculator, you go, oh yay, this is easy, I got it, here we go. Super simple. Bammo, done. Put it in your calculator. Know how to hit Math 9 and use the absolute values, because you don't have to do any thinking. You just got to memorize distance versus new position. Okay? Now, I haven't put this in my calculator yet, so I don't know what the answer is, so let me do that real quick. Okay, I'll talk you through it. You should already know how to do this and enter it into the calculator, but just in case you don't. It is Math 9 to get the absolute values. We're going from 0 to, to get the, not the absolute values. Math 9 was to get the integral. Going from 0 to 3. Make sure you plug in the absolute values. I find that it's easiest to do catalog, which is above the 0, because absolute value is the first thing in the alphabet on our catalog. Then plug in your velocity equation. We're going to use x's instead of t's. X squared minus 2x. Then put a dx at the end and hit enter. Yay. Expect that it might be a more difficult equation on your test, though. Also, remember, in this class, you will always, always, always round to the nearest thousandth. So this is approximately 2.6 repeating. We're going to call it 667 on the AP exam and everything ever, unless they tell you otherwise. It's always 3 digits. Since this was distance, I didn't give you a unit. It's x-axis, so we'll just say units. I should have given you a units per second or something like that. Okay, the next one, new position. So it's starting position plus net change. There you go. So take into account the -1 this time. Now put this in your calculator. Use your calculator, make your calculator look just like that. Hit the -1, the plus, and then the Math 9 all at one time. Because if you wait to add the -1 at the end, you might forget. So here I go. -1, not a -1. Your calculator will tell you you're stupid if you do that. Plus Math 9, 0 to 3 of the velocity equation without absolute values. X squared minus 2x and a dx at the end. And we get, -1. Well, that was interesting. I'm very tempted to look at the graph now and see why it seems to have gone, must have ended up where it started. Okay, that's kind of cool. It didn't mean for that to happen. That was just luck. So regardless, it ended up where it started, but you didn't even have to think about that. It's ending up at -1 on the x-axis. Okay, now we're going to do that same problem, both of those. You have to know how to do both of those without a calculator. The second one is no big deal. You're just going to integrate like normal. So it's -1 plus, when I integrate this, I would get t cubed over 3 minus, add 1 and divide, minus t squared, evaluated from 0 to 3. Keep that -1 out front. Keep your parentheses. Plugging in the 3, I would get 27 over 3, which is 9, minus 9, minus, plug in the zeros, and just be real careful with parentheses and your signs. And you can see that this one does give 0, so our answer is just -1. Now, on your test, if I give you one where you have a lot of ugly fractions here, keep in mind that you get most of your credit from knowing this and this. If this ends up being a bunch of ugly numbers, I would wait until the end of the test, make sure you have enough time. Don't get tied up in those fractions when this final answer is really not worth that many points, okay? Okay, you'll get graded on all the pieces along the way. Now, this one is what I want you to focus on. How do you handle integrating absolute values, okay? What you need to do is find anywhere velocity is negative and you need to make it positive and then integrate. And to turn a negative into a positive, if I have a negative number and I want to turn it into a positive, I need to put a negative in front of it. So anywhere velocity is negative, you're going to put a negative in front of it, which basically means change all the signs. Okay, let me show you how that's done. Okay, I'm going to do a velocity sign chart. So I set the factors equal to 0. Left of 0 is really dumb because there is no negative time. Okay, between 0 and 1, between 0 and 2, I'm going to plug in a 1 and I get a negative. After 2, I'll plug in a 3 and I get a positive. So that means from 0 to 2, my velocity is actually negative, and I need to flip that up to make it positive in order to integrate, because we're trying to do absolute value. Okay, so I'm going to integrate from 0 to 2. The opposite of this, I need to change them all to their opposites. So negative t squared plus 2t. Okay, change it to the opposite. Then I'm going to integrate. The rest is going to go from 2 to forever, but I'm stopping at 3. So from 2 to 3, I'm going to integrate, leave it as is. Okay? The math from here means you have to actually integrate and plug in a 2 and a 0 and subtract. Actually integrate, plug in a 3 and a 2 and subtract, and then add those answers. But the main idea here is, because I don't want to have a forever long video, you have to find where the velocity is negative and integrate that part, 0 to 2, that part you need to turn this into the opposite. Okay? All right, and you have more practice in the homework tonight. And that worksheet I gave on position and distance traveled, do a lot of practice problems on that. That's a key part of this test. All right, that's the hardest part of this test too, I think. The rest is going to be real quick. High speed. Here we go, Riemann sums. If it's a left Riemann sum, we use the numbers on the left, and we won't end up using this 2. Go back. All right, so make sure you show your work. The Riemann sum, a left Riemann sum would be subtract to get 5, use the number on the left, 7. Okay? Subtract, you get 1, use the number on the left, 5. Subtract, I get 1, using the number on the left, 4. And subtract, and I get 3, use the number on the left, 3. Okay? Multiply and add it up. There you go. So if you want to see why, remember, you can go back to the videos to see this a little bit slower, but the short of it is you've got a rectangle, so they're going to go from 0 to 5. I'm looking at the x-axis right now, then 5 to 6, then 6 to 7, and then 7 to 10. But the height of those rectangles, I'm using the height at the left point, so the height here is 7. The height of the next one is 5. The height of the next one is 6. And the height of the last one is 3. And you're finding the area of those rectangles. Okay? You can figure out the final answer on your own. Right Riemann sum, high speed, here we go. Starting on the right, it'll be 3 times the number on the right. So 3 times 6. Plus, subtract, you get 1 times the number on the right, 5. Plus, subtract, we get 1 times the number on the right, 3. And the last one, subtract, you get 3 times the number on the right, the 2. Okay? That is the estimated value of this integral, or area under curve. Midpoint rule. Oh, nope, I lied. Trapezoid rule. All right, for the trapezoid, you got to remember the formula for that trapezoid is 1/2 the height times the sum of the bases. So it's going to be 1/2 of the height is 3. Use both numbers. Okay, so for the left Riemann sum, we would have used just the 3. For the right, we used just the 2. For the trapezoid, you use both. But don't forget the formula is 1/2 the height times the sum of the bases for a trapezoid. Okay? Plus 1/2 of subtract, and you get 1 times, use both numbers, 2 plus 3. Plus, what did I do last? Okay, now I got to do this one. Subtract, I get 1/2 of 1 times 3 plus 5. And the last one, I ran out of room. The last one is 1/2 of 3 times 5 plus 6. Okay? Do your math, add it up, there you go. Last one, midpoint rule. The midpoint rule is the one that I actually do still have to draw because I'm dumb. And I just graph it every time real quick. 1 through 5. 1, 2, 3, 4, 5. 2 subdivisions. Make 2 random rectangles. I don't care if they're drawn to scale and have the wrong height. Could care less. Just get 2 rectangles. Then the height of those rectangles is determined by the midpoint. The height at 2 is 4. The height at 4 is 6. Find the area of these rectangles. So this was going to be 2 times 4 and 2 times 6. Okay, that's the midpoint rule. These are all estimated integrals. All right, moving on. See if you remember how to do these questions, okay? There will be some very similar to this. Hit pause, do your best. Notice on the first one I said nobody cares what's in the middle, whatever. I could put K of T in there. Nobody cares. If these bounds are the same, then when you plug in the same number and subtract, you better know that on the fly. That's clearly 0. Okay, slow down and do B, C, and D on your own. I want you to hit pause. Okay, f of x, there are no h of x questions, so I don't even need that. Don't let that confuse you. All right, we're going from -1 to 4, but we don't have -1 to 4 in either of these. We have -1 to 1, and we have 1 to 4. Well, the integral from -1 to 1 plus the integral from 1 to 4, because these numbers, this one ends where this one begins, is going to be the same as this. So it's just 5 plus -2, or 3. Now, if you don't remember why, you can add like that. This would be, graphically, the integral from negative, even if I don't pay much attention to the bounds, we're going from -1, there's f of x. If we go from -1 to 1, that's the area, so that's 5. Then we go from 1 to 4, and that's -2. Well, that actually means it's down here, but it doesn't really matter. So the total area is what you get when you add them together. You might want to see my video if that doesn't make sense to you, because I'm not sure I did a really good job on that one. Okay, the next one, we're going from 1 to -1, and we don't have that, but we have the reverse. So if I want to reverse those bounds, I have to change the sign. So that's -5. This one is a little trickster. It's not just get that answer and add 3 to the end. Okay, this one you have to find this integral plus apply the integral to the 3 as well. Okay, well this we know is 5. This, I don't have that up there, and you can't just add 3. What you need to do here is actually integrate with respect to x. Well, the integral of 3 is 3x, and now you got to plug in the -1 and the 1. Okay, so finishing that up, we would have a 5. I've got to write somewhere. Plus, when I plug in the 1, you get a 3. Minus, plug in the -1, you get a -3. So 3 plus 3, that's 6. So this answer should have been 11. A lot of people would have said the answer is 8, and that is not correct. This one is 11, okay? All right, if you want a better explanation of any of these, find the lesson that says integration rules, okay? All right, this guy, calculator question. This was yesterday's lesson, starting value plus net change, okay? If I want an antiderivative, I need to know another antiderivative. So f of 4, this has to be written on your paper. F of 4 will equal f of 1 plus the net change of the derivative from this number to this number, from 1 to 4. Okay, has to be that order. Then put it into your calculator. You don't have to write anything else. Please practice doing it so you can make sure you know how to do it in your calculator. Change the f of 1 to 1.8 plus, you don't need to write it though, then do all of it in your calculator, okay? So I have to do that right now, so I'll get the answer for you. So I'm going to plug in the 1.8. The f of 1 is 1.8 plus math 9, 1 to 4 of, be careful with putting this in. If you don't have the pretty little fraction bar, the way it's looking right here, if you don't have the 2 square boxes, if you don't know how to get that on your calculator, then you better make sure you put this in parentheses. So to get the little fraction thing, I use alpha y equals as its quickest way. Get your little fraction bar. 3x squared plus x minus 2. And I have an e to the x on the bottom. And then with respect to x. Sometimes your calculator can get a little slow on these. Okay, final answer rounded to the nearest thousandth is approximately 5.835. Okay? All right, let's see. Do I have anything else? Ah, dang it. There's still more. Woof. All right. I give you a derivative. That derivative stands for how fast hula hoops are being sold. Oops. Sorry about that. Okay? How fast. I'm giving you a rate. This is a hint. It's also a rate. Don't have to do that. Okay? If this is a rate and I'm asking for the total, then we integrate. So it's the integral of this guy from 0 to 3 because it's the first 3 years. You could also just say from 0 to 3 dHdt, whatever's easiest to write down, and then know how to put it in your calculator and know how to do it by hand. Same thing with this one. This would definitely be a calculator question though. Okay, take the time to read it before moving on. Hit pause and see if you can at least set it up and write down the bare minimum that you would need to write on your paper to get credit. Okay, how much water is in the pool? Well, it starts with 600 cubic feet. Then we're going to add some amount and subtract some amount. Okay, again, these are rates, so we have to find their totals first. If this is cubic feet per hour, then when I integrate, I'll get the cubic feet, which is the amount of water. Okay, so we just need to pay attention to which one's adding and which one's subtracting. Okay, water is leaking out at this rate, and the time frame for that is 0 to 8. Water is being pumped in at this rate, and the time frame for that is 6 to 8. Okay, put all of that in your calculator. And you can write everything exactly as you see it right in your calculator. Hit the 600 plus math 9 minus math 9 again. Just be real careful and actually practice that so you can make sure you get it right. I'll do it on my calculator now. Okay, rounded to the nearest thousandth, I get 578.832 cubic feet of water. Okay? Now, FYI, if these equations have any trig in them, sine, cosine, or whatever, make sure in this class you are always in radian mode. It's automatically the standard or the go-to that your calculator should start in, but if you're in physics or using it in science class, you might change it to degrees. You want to always, in this class, on any test and the AP exam, make sure you are in radian mode. All right, guys, that's it. I wasn't sure. I had to let it tell me. Good luck. Do the round the room review, and your test is tomorrow. Good luck. You got this.